Let's code a ERC1155 contract. First, I'll import some interfaces that we'll need to implement. Here's an interface for ERC1155, and we also need an interface for ERC1155 token receiver. This will be a contract that will be called when a token is transferred from to another contract and the receiver is a contract. I'll explain more about it later. I'll start off by writing contract. I'll name this ERC1155, and we'll implement our ERC1155 inside here. The function to mint and burn tokens are not part of ERC1155, so I'll create another contract. I'll name it my multi-token, and this will be ERC1155. And inside here, we'll implement the function to mint and burn tokens. And here are the functions that we'll implement later: mint, batch mint, burn, and batch burn. Okay, so let's start with the base contract ERC1155. So this will be is ERC1155. And of course, we haven't implemented any of the functions inside here. So first, I'll copy all of the functions inside here, inside the interface, and then paste it inside our contract. And to remove the compilation error, I'll make all of these declarations into functions. Okay, once that's done, next I'll declare the events that we need for ERC1155. Here are the events that we'll need: transfer single, transfer batch, approval for all, and URI. We'll go over what these mean later as we implement the functions. Okay, so next, let's declare some state variables. So the first state variable that I'll declare is the balance of token for a user. So ERC1155 can manage multiple tokens, so you'll need a nested mapping. A mapping from owner to some token ID, and then from the token ID to the balance of the token. So this will be mapping owner address, and then to another mapping ID will be uint256, and then lastly the balance of the token, uint256. Public, and I'll name this balance of. Now I see a compilation error over here on the bottom. This is because we need to implement the function balance of, and by declaring the state variable balance of, we no longer need this. So going back up, the next state variable that I'll declare is some kind of approval to transfer tokens. So this will be a mapping from the owner to the operator. Operator is an account that will be able to spend the tokens from the owner, and then from the operator, whether this operator is approved or not. So this will be a Boolean. So mapping address owner to another mapping address operator or the spender, and Boolean whether this operator is approved to spend owner's token or not. Public, I'll name this is approved for all. And again, there's a compilation error down here. We need to implement this function, and we already did that by declaring the state variable, so we no longer need this. Okay, going back up. The next functions that I'm going to implement are metadata informations. So scrolling down, the first function for the metadata that I'm going to declare is called supports interface. And it basically tells other contract that this contract supports the interface for ERC165, ERC1155, and ERC1155 metadata URI. And I've also declared another function for the metadata, ERC1155 metadata URI. These two functions are not that interesting, so let's move on. So the first function that is interesting is the function to mint. Now this is not part of the ERC1155 standard, so I'll make this mint function an internal function. And then later we'll call it inside our my multi-token. So say function, just to remind us that this is an internal function, I'll name this with an underscore mint. And the parameters that's going to take are address to uint256, ID of the token, uint256, the amount of token to mint, value, and if the receiver of this token, if the to address is a contract, then we'll have an optional data that we'll pass. So say bytes memory data. This function will be internal. So inside here, what we're going to do is update the balance of 2 for token ID, And if 2 is a contract, then we'll call some callback. So first, let's require that this 2 is not a 0 address. Require 2 is not equal to address 0. Error message 2 is 0 address. Next, we'll update the balance of 2. So how do we do this? Let's go back up, and we set that the state variable balance of is a mapping from owner ID to balance. So I'll copy this and then paste it here for a reminder. So we need to update the balance of owner will be 2, the token ID will be ID, and then we'll increment it by value. Okay, next we'll emit the event transfer single. So what are the parameters that we need to emit? Copy all of this, scroll back down, paste the event. So we'll emit this event, and the parameters, the operator will be the caller that called this function. So I'll say message.sender from, when we mint, we usually say address 0. So say address 0. 2 will be the 2 from the input, ID will be ID, and value will be value. Next, we'll need to check whether 2 is a contract or not. And if it is a contract, we'll need to call callback. To check whether 2 is a contract or not, you'll say if 2.code.length is greater than 0. If there is a code at the address of 2, then we know that it is a contract, so we'll need to call callback. The callback that we'll need to call, is scrolling up, is on ERC1155 receive. Let me copy this, and then going back down, I'll paste the interface and say ERC1155 token receiver at the address 2, and then the function that we need to call is on ERC1155 received. And these are the parameters that we'll need to pass. Operator is message.sender, from will be address 0, ID will be ID, value will be value, and the data that we will pass to this callback will come from the input over here. So calling this function on ERC1155 receive, we expect to receive an output of bytes 4. And this bytes 4 must match the selector of ERC1155 token receiver dot on ERC1155 receive dot selector. So these must match, or else we'll have to throw an error. So say require, calling this callback, the selector that was returned should match this selector. If it does not, we'll throw an error message on safe transfer. Okay, that completes the function, the internal function to mint. The next function that I'll write is an internal function called batch mint. So here I'll type function underscore batch mint. This function will be internal. What this function does is basically the same thing as mint, but we'll be able to mint multiple tokens to some single address. To this address, you'll be able to mint multiple tokens for different amounts. And lastly, we'll pass in data. First, we'll require that 2 is not equal to 0 address. And to do that, I'll just copy this code over here and then paste it over here. Next, we want to make sure that the length of IDs and the length of values are the same. So say require IDs.length is equal to values.length. Error message, let's say IDs length not equal to values length. And then next, we'll run a for loop to mint multiple tokens to address of 2. So to do that, first I'll copy this, paste it here, and we'll have to do something like this inside the for loop. So say for uint I equals 0, I less than IDs.length, I plus plus, and then we'll update the balance of 2. The ID will be stored in IDs of I, and value will be stored in values of I. And then after we do this, we'll emit the event. Scrolling up, the event that we'll emit is this event. We'll paste the event, say emit. Operator will be message.sender. From will be address 0. We're minting from address 0. 2 will be 2 from the input. IDs will be IDs, and value will be values. And again, if 2 is a contract, then we'll have to do something similar to this code over here. So I'll copy this code first and then paste it here. But the callback that we need to call is slightly different. The callback that we need to call is this one over here. It's called on ERC1155 batch receipt. So I'll copy this function, go back down, and then I'll paste the function over here. So this is the function that we'll need to call. So the function that we'll need to call is called on ERC1155 batch received. Operator will be message.sender, from will be address 0, IDs will be IDs, values will be values, and data will be data. And again, calling this function should return a selector of on ERC1155 batch received. And the error message, we'll keep it the same. Okay, so that completes the function for the internal functions for mint and batch mint. Let's call those internal functions inside our myMulti-token. So inside myMulti-token, the internal function to mint, I'll copy this so that I remember what parameters I need to pass in what order. We'll call the internal function mint, address to, let's say, message.sender, ID will be ID, value will be value, and data will be data. Okay, and we'll do something similar for batch mint as well. So going back up, I'll copy the parameters so I know how to call this internal function. Scroll down, paste the function. We're going to be calling the internal function batch mint. To will be message.sender. Next parameter will be IDs. The next parameter will be values. And the last parameter will be data. And that completes the function for mint and batch mint. These two functions are not part of ERC1155, but the code inside these functions tell us how we need to update the balance of and what other functions that we'll need to call. For example, when we do a transfer, we'll need to call the callback on ERC1155, received or batch received. So next I'm going to declare some internal functions for burn and batch burn. Let's start with burn. Function underscore burn. The parameter that we'll pass is address from, the account that we're burning the tokens from, token ID, uint256 ID, and the amount to burn, uint256 value. This will be internal. Let's recycle some of the code inside the internal function mint. So I'll just copy this, then go back down, paste it here. We'll require that from is not equal to address 0. Error message from is equal to 0 address. Next, we'll need to update the balance of. So it'll be balance of from. Instead of adding, we'll minus. And then lastly, we'll emit the event, and we don't need this callback. Operator will be message.sender. From will be from. To will be address 0. And ID and value will be the same. Let's write a similar function for batch burn. What I'm going to do is copy the internal function for batch mint, and we'll modify this to create an internal function for batch burn. So I'll call this batch burn. Parameter will be from, ID, values. We don't need data. So since we don't need data, we're not going to need the callback. And we'll require that from is not equal to address 0. With the error message, from is equal to 0 address. And then next, we'll check that the length of IDs is equal to the length of values. Next, we'll run a for loop to update the balance of from for IDs, minus it by values of I. And lastly, emit the event transfer batch operator message.sender from to will be address 0, and the rest of the parameters are the same. Okay, so that's batch burn. Next, let's call those internal functions inside our myMulti-token. Here, we'll call the internal function burn from message.sender token ID amount value. And we'll do something similar for batch burn. Say underscore batch burn from message.sender. IDs will be IDs, values will be values. Okay, so that completes the internal functions for mint, burn, and batch burn. Later, we'll be writing similar code for a safe transfer from, which is part of ERC1155. But before we do that, I want to implement some other functions. The first function that I want to implement is batch balance of. So I'll copy these two functions and then move it up here. And let's start with batch balance up. What this function will do is get the balance of owners for the token IDs. First thing that I'll do is initialize a uint256 array. This will be an array of balances that we'll be returning, balances. Okay, next we'll check that the length of owners and IDs are the same. So say require owners.length is equal to IDs.length. Error message owners length not equal to IDs length. Inside Solidity, when we initialize an array of memory, we need to tell the length of this memory array. So to do that, we'll say balances is equal to new uint bracket, and the length of this array will be the same length as the owners array, owners.length. Next, we'll get the balance of owners. So say for uint I equals 0, I less than owners.length, I plus plus. And then say balances of I is equal to, we need to get the balance from the state variable balance of, from the owner, owners of I, for the token IDs of I. And that completes the function for balance of. Now notice that we didn't have to say return balances. This is because we initialized an array over here for returns, and then we just put some values inside here. So that completes the function for balance of. Next, let's write a function set approval for all. So this function will either give or revoke approval for operator. The state variable that we'll need to update is this one over here, is approved for all. I'll copy this comment over here, paste it here. We'll say is approved for all. Message.sender, that will be the owner, approves the operator from the input, either approves or revokes by the Boolean input approved. And then we'll need to emit the event approval for all. Copy this event, paste it here, emit approval for all. Owner will be message.sender, operator will be operator from the input, operator, and approve. Okay, that completes the function set approval for all. We have two more functions that we'll need to implement. Safe transfer from and safe batch transfer from. Let's start with safe transfer from. So I'm probably gonna reuse some of the code from the internal function mint. So I'll copy this and then paste it over here. And we'll modify this code. When we call the function safe transfer from, we want to check that either message.sender is equal to from. In other words, message.sender is the owner of token to be transferred. Or we want to make sure that message.sender has approval from the address from. So to do that, I'll say require either message.sender is equal to from or is approved for all from operator message.sender. And then the error message not approved. Next, we'll check that 2 is not equal to address 0, and then we'll update the balance of. So the balance of from should decrease, and the balance of 2 should increase. And we'll emit event from to ID value. And then lastly, we'll call the callback on ERC1155 received if 2 is a contract. Operator will be message.sender. From will be from the input. ID, value, data, rest of it is the same. And that completes the function for safe transfer from. And the last function that we'll implement is safe batch transfer. And again, we'll start off by copying the code from batch mint. So copy this code and then paste it here. Just as what we did for safe transfer, we want to make sure that either message.sender is the owner or message.sender is approved by the address of from. And then we'll check that 2 is not equal to address 0. We also check that ID's length is equal to value's length. And then next we'll run a for loop to update the balance of 2 and also the balance of from. So I'll copy this, paste it here. Balance of from for IDs of I, decremented by values of I. And then increment the balance of 2. Emit the event transfer batch for from to IDs values. And then lastly, call the callback. We'll just need to update this input from. And that completes the function for safe batch transfer from. And we've now implemented all of the functions for an ERC1155 contract. Let's try compiling this contract and make sure that there's no error. So open my terminal, clear the logs, and then type forge build. And our contract compiled successfully.